Hi, I'm Matthew Ray from Harmony Schools. Our group is made up of Azalea Rodriguez, Thomas Arboleto, and I. We are all attendees of Harmony Science Academy San Antonio and in the 8th grade. We are doing a project that compares a 2-yard dumpster and an icosahedron. We strive to find out if the capacity of the icosahedron is larger than the 2-yard dumpster. Our project is, can an icosahedral shaped dumpster have a larger capacity than the 2-yard dumpster?
Our project is comparing a 2-yard dumpster and an icosahedral shaped dumpster and seeing which has a better capacity and which is more beneficial to society. Okay, so we're going to start with the volume of the 2-yard dumpster, and the formula for volume is length times width times height right here. And for the dimensions of the 2-yard dumpster, there was 2 different heights, so we're going to have to calculate volume 2 times with the 2 different heights, and then we're going to have to subtract the 2 and we'll get the official volume. So with the first dimensions of one of the heights would be 6 times 3 times 3, and that would be 18 times 3, and that would be 54 feet squared. And then we calculate the other volume, well, with the other different height, and it would be 6 times 3 times 0.5, and 18 times 0.5 is 9 feet. And then we subtract 54 minus 9, which equals 45 feet. And 54 and 9 are the 2 different volumes. And once you subtract those 2, you get the official volume of the 2-yard dumpster. And then for calculating surface area is basically just the area of each 2-dimensional object that makes up the 3-dimensional object. So we're going to calculate the area for each side of the 2-yard dumpster, and using all the dimensions, it's 6 sides. And 6 sides would be 3.5 times 6, which equals 21, 6 times 3, which equals 18, 6 times 3, which equals 18, 3.5 times 3, which equals 10.5, and 3 times 3, which equals 9. And now that we have all the areas, then we add them all up to get surface area. And then once you add them all up, you get 67.5, and that's the surface area. So we have surface area and volume for the 2-yard dumpster, and now we have to find the volume and surface area for the icosahedral shaped dumpster. For volume for icosahedron, there's a special formula. Its volume equals 5 times 3 plus the square root of 5 divided by 12 times a squared. And in this, a is the length of the edge and on the edge of the icosahedron. And the icosahedron is made up of 20 equilateral edges, so all the lengths will be the same in the equilateral triangle. You just plug in the length of the edge into the equation, and you rewrite the equation, and you just put in 2.75 cubed.
These are magic.
And then you do 15 plus 5 times 3 plus the square root of 5, which comes out to 15 plus 11.18, and then you divide that by 12, and you times that by the square root. 26.18 divided by 12, and the cube of that, and then you multiply the 2, and then that gives you the volume. Now you have the volume of the icosahedron. Now we have to find the surface area. In order to find surface area, the icosahedron is made up of 20 equilateral triangles, so you have to find the surface area of one and just times that times 20. So, but we don't have the height in this case because the formula for the triangle is one half times base times height. So what we have to do is we have to use Pythagorean theorem to find the height, because all we have is the length of the base. So using Pythagorean theorem, the formula for that is a squared plus b squared equals c squared. So all that's missing is a. So we just plug in the other numbers and leave a blank, and it's 1.4 squared and 2.8 squared, and in this case 2.8 is c and 1.4 is b. And then we find square roots of each in 1.96 and 7.84. And then once we have the 2 values that are already squared, we have to subtract them. And once you subtract them, you get 7.84 minus 1.96, which equals 5.88. And once you get that, you have to square root that, and then I'll give you your height. which is 2.42. And now you have to plug in the height into the equation of the area for the triangle. So 1/2 times base times height. So surface area equals 1/2 times 2.8 times 2.42, which is the base and the height. And then once the base and the height are multiplied, that equals 6.78, and then you have to multiply that times half. And once that is multiplied, you get 3.39. But you have to take into account that there's 20 equilaterals and 20 equilateral triangles, so you have to multiply whatever the area is times 20, and that gives you 67.8 feet squared, which is the surface area. Okay, so the volume for the 2-yard dumpster was 45, and the volume for the icosahedron was 45.32. So the icosahedron has 0.32 bigger volume. The surface areas for 2-yard dumpster was 76.5 and 67.8. And the icosahedron has a smaller surface area, which means even though it can hold more, but it's more compact. So, what this means is the icosahedron is more beneficial to society.
For our ELA component, the icosahedron can be used a lot in today's society. It can be used to benefit and solve problems today, like the issue of garbage. It is much better and more beneficial to society than a mundane 2-yard dumpster.
For our social studies component, we wanted to find how the icosahedron affected today's society. For example, a soccer ball is a type of icosahedron for its use of multiple pentagon and hexagon faces. The history of the icosahedron traces back to the times of Plato. It's amazing to think how something so ancient can still affect society in the modern era.